Good evening. I'm so excited to share with you some of my lab's latest research that have been changing the way we understand sleep problems in aging and Alzheimer's disease. I'm a neuropathologist. The Memory and Aging Clinic at UCSF, most of our research participants, they donate their brain for research to our brain bank. And when my lab and I will receive these brains, we want to make sure we honor them and they make the best out of it to find a cure for the disease that afflicted them. So for instance, we developed some tools that we can make a brain that looks like a jelly to be fixed in a 3D printed skull so we can have the same shape that the brain had inside the skull. And then, after we cut this brain in very thin sections like this, we can fit 20 sections in 1 millimeter. We can use supercomputers to reconstruct all this in 3D and really have a deep look in what is going on. Today we are talking about one of my favorite topics, music and sleep. And Kamalini and Liza showed us how the brain oscillates with different waves during the different stages of sleep and awake. As a neuropathologist, I'm always curious to understand how the brain is orchestrating all this. And it seems that it takes a village. Sleep is a very complex process. So it requires some group of neurons specialized in keeping us awake, this one in blue. And then there is another set of neurons that are specialized only in producing the kind of sleep that we dream, the REM sleep. And finally, another set of neurons that regulates our sleep. So how all of them can work together? They need a conductor. And the conductor is another set of neurons that's our master sleep clock. So imagine these are the neurons that keep us awake. So when the master brain clock tells, okay, now it's time to go to sleep, very quickly these awake neurons shut down and the awake neurons, the sleep neurons turn on. That's a very beautiful process. Now, I like to travel a lot, and one thing I would like to improve in my travel is my sleep. If I cannot be jet lagged, it will be awesome. And I'm sure that many of you have certain sleep problems that would like to deal better with it. So how do we learn about sleep in our very unique human brain? Well, one of the ways to do it, and this is a way my team and I use, is to take a disease that causes a problem in the brain, called these naturalistic lesions, and understand how it behaves, for instance, for sleep. So we can learn better how sleep, for instance, works in the human brain. And Alzheimer's disease, it's a very special one, not only because it's very common, but it also causes sleep problems in most of the patients. When we talk about Alzheimer's disease, we talk of accumulation of certain trash, protein trash in the brains. We have amyloid plaques, this one on the left, and we have tau tangles on the right. We have been studying amyloid plaques for longer, and we know that accumulation of these amyloid plaques disrupt our sleep. And this is very bad, because exactly when we are sleeping, our system flushes out all the dirty from the brain. So if we don't sleep well, we accumulate even more amyloid and other trash proteins. Now, people with Alzheimer's disease, they tend to feel sleepy during the day, they take more naps, and we have been thinking that it happened because they need to compensate the bad night of sleep. Now, in Alzheimer's disease, we also have these tau proteins, sticky proteins that accumulate inside the neurons, these brown things, and clog them. I have been working with tau protein for many, many years, and one of my first discoveries was to show that actually the deep parts of the brain are the ones that are the first to accumulate these tau proteins. Now, I have been looking at this deep part of the brains every day for many years. And one day I had this eureka moment saying, wait a moment, all the neurons that promote our awake, they are the same ones that are the first to accumulate tau in the brain. So the question came, is it possible that this tau, early stages of Alzheimer's disease, are causing problems in these awake neurons, and this is why people are not feeling sleep during the day? So one of the first studies we did to try to understand this was together with Kamalini, and what we did was to look at the data of our research participants that did EEG to measure their sleep when they came to our clinics and donate our brains. And then we could realize that the worse of the alpha synchrony, the worse their waves during awake look like, more tau they had on the brain. So we were so excited by this result that we decided to really do the very complicated work that took many years of looking at many brains. We counted neurons in these very small areas that promote awake. And what we concluded is that if we look at any one of these areas, at least 2/3 of these neurons die during Alzheimer's disease. So this shows us, well, probably this is the explanation why people are not being so awake during the day. But speculation in science is not good enough. So we did another study that probably took about 10 years. So our team followed patients that came to our clinics, and they did this polysomnography, or they measured the brain oscillation during the day. And when they donate the brains many years later, we went through this work of counting neurons. And finally, we could combine data from the same patients, from the sleep data and from the neuropathological data. And by doing this, we could show, luckily, exactly what we were looking for, that the less we have the numbers of wake promoting neurons, more time people sleep, of course, because they cannot wake up so quickly. More they can maintain that sleep, and less they wake up after they fell asleep. It might seem good, but in this case, it's not so good, because it means that the wake system is not working very well. Now, maybe you are thinking, well, I took a nap last week. Do I have Alzheimer's disease? Should I be worried? I would be, but actually, I want to finish here with a very good message. So first of all, we are learning more and more that sleep is good for us. And there are many things we can do, even not related to drugs, like better sleep habits or even treating sleep apnea, that will help us sleep better and not accumulate this trash. Also, this kind of research that I just showed you, that we look in the brain very deep, are showing us that many drugs that exist now to treat psychiatric disease because they balance the brain chemistry are the same brain chemistry that are produced by these awake-promoting neurons. And now we know better how to use them to control sleep. Also, if experimental studies, the one we do with mice and flies, are correct, we know that just by balancing this brain chemistry, we can avoid that Alzheimer's disease progress fast. So maybe even by sleeping better, we can have less memory problems later on. And finally, there is some cautioned optimism with some new drugs that seems to be treating this very trash that accumulate in Alzheimer's disease. I hope I gave you a better message now, and you can enjoy a lot your sleep tonight and in all the other nights. Thank you very much.
Welcome to Act 3.